Imagine standing under a night sky that seems alive, where colours dance and ripple above you in ways you've never seen. These are the Northern Lights, one of nature's most mesmerising spectacles. For centuries, people have gazed upward in awe, trying to understand their beauty and mystery. But beyond the breathtaking colours lies a fascinating story of solar winds, magnetic fields, and cosmic energy. In this script, we'll uncover 100 incredible facts about the Northern Lights that will make you see them in a whole new way. Fact 1. What are the Northern Lights? Imagine standing outside on a crisp, quiet night, and suddenly the sky above you comes alive with waves of green, purple, and pink. It feels almost like the sky is dancing, and you can't look away. That's the Northern Lights, or as scientists call them, the aurora borealis. But what exactly are they? At their core, the Northern Lights are a natural light display caused by particles from the sun colliding with Earth's atmosphere. When these charged particles hit gases like oxygen and nitrogen, they emit light, painting the sky with stunning colours. You might think this happens everywhere, but it's actually concentrated near the North Pole, giving it that northern name. People have been fascinated by these lights for thousands of years. Early explorers, travellers, and even those living in Arctic regions would record sightings, often describing them as dancing flames or sky rivers. Of course, today we understand the science behind it, but the experience is still just as magical. Interestingly, the Northern Lights are not constant. Some nights they're faint, like a misty glow on the horizon, while other nights they explode across the sky in waves and curtains of colour. This unpredictability is part of the charm, and part of what makes aurora chasing so addictive. Travellers will plan trips to places like Norway, Iceland and Alaska, sometimes waiting hours or even days for the perfect display. Even though the science explains the how, it doesn't take away from the awe. There's something deeply humbling about watching these lights ripple and shimmer overhead, a reminder that Earth is part of a much larger dynamic system, and if you ever get the chance to see them in person, you'll understand why people keep returning to the Arctic year after year. Fact 2. Aurora borealis versus aurora australis. Most of us are familiar with the Northern Lights, but did you know there's a southern twin? It's called the aurora australis, or the Southern Lights, and it lights up the skies near the South Pole. While they're essentially the same phenomenon, caused by solar particles colliding with the atmosphere, their locations give them slightly different viewing experiences. The Northern Lights, as you might guess, are more accessible. Countries like Norway, Canada, and Iceland have entire tourism industries built around aurora chasing. The Southern Lights, on the other hand, are harder to see. You'd need to be in Antarctica, Tasmania, or the southernmost parts of New Zealand. That remoteness makes the aurora australis a little more mysterious, but equally stunning. In terms of colour and shape, both auroras behave similarly. You'll see those iconic greens, purples and reds, forming arcs, curtains and waves across the sky. Sometimes, when solar activity is intense, the aurora can even stretch toward lower latitudes, giving lucky observers far from the poles a rare chance to catch a glimpse. Interestingly, scientists study both auroras together because they mirror each other in fascinating ways. When a solar storm hits Earth, the northern and southern lights often react simultaneously. It's like the planet is having a synchronized light show, reminding us how connected the two poles really are. Fact 3. Why they appear only near the poles. If you've ever wondered why the Northern Lights are northern and the Southern Lights are southern, the answer lies in Earth's magnetic field. Think of our planet as a giant magnet with invisible lines running from the North Pole to the South Pole. Charged particles from the Sun are funneled along these magnetic lines, colliding with atmospheric gases mostly near the poles. This is why you rarely see a brilliant aurora in places like Florida or southern Europe. The magnetic field simply doesn't guide the solar particles there. Instead, they get directed to higher latitudes, creating a concentrated light show near the poles. Scientists call these areas the auroral ovals, and they expand and contract depending on solar activity. Occasionally, during strong solar storms, the auroras can dip lower in latitude, making headlines when people hundreds or even thousands of kilometers south catch a glimpse. But for the most reliable and intense displays, the Arctic and Antarctic regions are still the prime spots. There's also an interesting seasonal factor. The polar winter, with its long, dark nights, provides the perfect backdrop for the aurora. It's not that the lights don't happen during the day, they do, but sunlight overpowers their glow, making them invisible. Fact 4. The colours of the aurora. Explained. When people first see the northern lights, they often gasp at the colours: greens, reds, purples, and sometimes even blue. But why do they appear this way? The secret lies in the gases in Earth's atmosphere. Oxygen is responsible for the most common greenish hue. When solar particles collide with oxygen about 100 kilometers above the ground, it emits green light. Red auroras are rarer and occur higher up, above 200 kilometers, where oxygen atoms release red wavelengths. Nitrogen, on the other hand, produces blues and purples when it interacts with solar particles. What's fascinating is that the same aurora can display multiple colors at once. You might see a curtain of green with streaks of purple running through it. The shape and movement also affect how colors appear. Wavy curtains, spirals, or arcs can make the light seem almost alive, changing tones as they ripple. If you've ever seen photos of the aurora, you might notice the colors look even more intense than in real life. That's because cameras often capture light differently than our eyes, sometimes revealing subtle blues and purples that are harder to notice naturally. Still, even to the naked eye, the display is mesmerizing. Fact 5. How solar winds create the lights. At the heart of the northern lights is a cosmic connection with the sun. Every day the sun sends out a stream of charged particles called solar wind into space. Most of these particles pass harmlessly by Earth, but when they collide with our magnetic field, things get interesting. The magnetic field directs these particles toward the poles, where they crash into atmospheric gases. Each collision excites the gas atoms, causing them to emit light, the colourful, shimmering display we know as the aurora. Strong solar winds, often caused by solar storms or flares, can intensify auroral activity, producing brighter and more widespread displays. Aurora-chasing enthusiasts pay close attention to solar activity because it helps predict when the lights will be most impressive. Apps and websites track solar storms in real time, allowing travellers to plan their trips around peak aurora activity. It's science and adventure rolled into one. Interestingly, solar wind doesn't just create beauty, it can also affect technology, from satellites to power grids, reminding us that the aurora is a spectacular but powerful natural phenomenon. Fact 6. Role of the Earth's magnetic field. Imagine Earth as a giant magnet with invisible lines stretching from the North Pole to the South Pole. These lines aren't just for show, they play a key role in creating the northern lights. The Earth's magnetic field acts like a funnel, guiding charged particles from the Sun toward the polar regions. Without it, the particles would mostly miss our atmosphere, and the spectacular light show we love would be far less frequent. The magnetic field doesn't just direct particles, it also shapes the auroras. Think of it as a cosmic traffic controller. When solar particles approach Earth, they follow these magnetic lines, spiraling down toward the poles. Once they collide with oxygen or nitrogen in the atmosphere, they emit light, producing the shimmering curtains of color we see. Interestingly, the strength and orientation of the magnetic field can affect the aurora's location and intensity. Sometimes, magnetic storms caused by solar flares push the auroras further from the poles, letting people hundreds of kilometers south catch a glimpse. Other times, the field channels the particles so precisely that the lights appear as narrow, focused bands across the sky. The magnetic field is also why auroras form in roughly oval shapes around the poles. Scientists call these areas auroral ovals, and they expand and contract depending on solar activity. So every time you see the northern lights, you're actually witnessing Earth's magnetic field in action, silently orchestrating a stunning cosmic performance. Fact 7. Interaction with the atmosphere. The magic of the northern lights happens where the solar wind meets Earth's atmosphere. When charged particles from the sun collide with gases like oxygen and nitrogen, they transfer energy, exciting the atoms and causing them to emit light. This interaction is what paints the sky with those mesmerizing colors. Different gases produce different colors. Oxygen gives us green and red hues, while nitrogen is responsible for blues and purples. The altitude at which these collisions occur also matters. Closer to the ground, the auroras often appear green. Higher up, they can glow red or purple. This explains why the lights sometimes have layered or gradient effects like nature's own neon sign. The atmosphere doesn't just provide color, it shapes movement too. winds, temperature layers, and magnetic activity all influence how the aurora flickers, bends, and ripples. Even though these motions look chaotic, they follow predictable physical laws, which is why scientists can forecast aurora activity with some accuracy. Next time you watch the northern lights, remember, what you're seeing is a direct interaction between Earth and the Sun, a dance of particles and gases that has been happening for billions of years. It's a rare glimpse into the invisible forces that surround us every day. Fact 8. Why aurora shapes change. If you've ever seen a photo of the northern lights, you might notice they rarely stay still. One moment, you'll see soft, diffuse glows. The next, dramatic ribbons, arcs, or curtains stretching across the sky. But why do auroras change shape so dramatically? The answer lies in the solar wind magnetic field, and atmospheric conditions working together. Charged particles spiral along magnetic field lines, but variations in speed, density, and direction cause shifts in the aurora's pattern. Add in atmospheric winds, and you get a constantly moving display. Shapes also depend on altitude. High-altitude auroras often appear as smooth arcs, while lower ones can break into intricate, rippling curtains. Strong solar storms can even create vertical rays or shimmering folds that look like giant moving sheets of light. It's this ever-changing choreography that makes aurora watching so mesmerizing. You never see the same display twice. Fact 9. The science behind the flicker. Have you ever noticed how the northern lights sometimes flicker, shimmer, or dance rapidly? That flickering is more than just aesthetics. It's a window into complex physics. When charged particles hit the atmosphere, they don't do so at a steady pace. Variations in solar wind speed, density, and the magnetic field create bursts of energy that produce brief, flickering flashes. Some scientists compare it to watching fireworks in slow motion. Each flash represents a tiny collision of particles, but when millions occur simultaneously, you get waves of movement that ripple across the sky. Even though it looks random, these patterns can reveal information about the sun's activity and the magnetic environment surrounding Earth. So, when the aurora seems to dance wildly, you're actually witnessing a high-speed interaction of cosmic forces that span millions of kilometers. That flicker is like a heartbeat of the magnetosphere, a reminder that the universe is never truly still. Fact 10. How altitude affects color. One of the most fascinating aspects of the northern lights is how their colors change depending on altitude. Most of the green auroras appear around 100 kilometers above the ground, where oxygen atoms are abundant and collisions with solar particles are frequent. Red auroras, on the other hand, occur much higher, above 200 kilometers, where oxygen atoms emit red light when excited. Nitrogen contributes blues and purples, usually appearing lower than red but higher than green. The combination of gases and altitudes creates the layered gradient effects often captured in photos. Sometimes, you'll even see multiple colours stacked on top of one another, forming a natural light painting across the sky. Altitude doesn't just affect colour, it also affects brightness and shape. Higher auroras tend to appear thinner and more diffuse, while lower auroras are brighter and more defined. That's why, when you're chasing the northern lights, positioning yourself properly and understanding the atmospheric layer you're observing can dramatically enhance the experience. Fact 11. First recorded sightings in history. The northern lights have captivated humans for thousands of years, long before we understood the science behind them. The earliest recorded sightings come from civilizations living near the Arctic Circle, where the lights were an everyday yet mesmerizing part of life. Early observers described them in vivid, often poetic terms, as glowing flames, rippling curtains, or mysterious fires in the sky. What's remarkable is how these early records blend observation with imagination. Travelers and explorers wrote diaries noting the colors, shapes, and frequency of the auroras. Some chroniclers even recorded unusual auroral events, like red lights stretching across the horizon or auroras visible far south of their usual range. These records later became essential for scientists trying to understand the aurora's patterns over time. Archaeological evidence, such as carvings and artwork in northern communities, also suggests that people have been inspired by the lights for millennia. While we now know the auroras are caused by solar particles colliding with Earth's atmosphere, these early records show that humans have always been drawn to the spectacle. The awe these lights evoke hasn't changed a bit. Fact 12. Aurora in ancient Greek texts. Even ancient Greek scholars took notice of the northern lights. While the Greeks didn't fully understand the phenomenon, they wrote about unusual lights in the northern sky with curiosity and wonder. Some texts described the aurora as flames dancing on the horizon, or sky rivers glowing with colours. What's fascinating is that the Greeks tried to connect these events to natural causes, even without modern science. They speculated about air, fire, and atmospheric effects, showing an early desire to explain what they observed. While their ideas were limited by the knowledge of their time, these records are some of the earliest documented attempts to make sense of the aurora as a natural phenomenon rather than pure superstition. It's also interesting to compare these texts to other cultures' interpretations. Where the Greeks leaned toward observation and theory, northern cultures often told stories to explain the light's presence. This contrast highlights how universal the aurora's appeal has been, inspiring curiosity in both scientific minds and storytellers alike. Fact 13. Northern Lights in Norse mythology. People living in Scandinavia have long been fascinated by the Northern Lights, and Norse mythology offers some of the most vivid historical interpretations. While the lights weren't considered supernatural in the way of deities, early Norse stories often described them as reflections of mythical events, or signs of heroic deeds. One common idea was that the auroras were reflections from the shields of the Valkyries, mythical figures associated with battle. Others thought the lights were signals from the heavens, guiding warriors or marking significant events. While we now understand these tales as symbolic, they reflect how humans historically sought meaning in natural phenomena. Even today, Scandinavian communities carry forward a sense of wonder when viewing the auroras, bridging history, culture, and science in one breathtaking experience. And while these myths are entertaining, they also remind us how universally inspiring the Northern Lights have been across generations. Fact 14. Inuit interpretations. For the Inuit people of the Arctic, the Northern Lights were more than just a beautiful sky show. They were woven into daily life and storytelling. In some Inuit traditions, the lights were seen as playful spirits moving across the sky or as signals from ancestors. These interpretations emphasized observation, respect, and a deep connection with nature rather than fear. Interestingly, Inuit stories often described auroras as interactive, almost alive. Some tales suggest the lights could respond to human actions, like whistling or waving, adding a playful element to the experience. These cultural interpretations show that the auroras were not just a visual phenomenon, but also a central part of community identity, storytelling, and understanding the environment. Even today, Inuit guides share these stories with travelers, providing a richer perspective on the aurora. Combining ancient interpretation with modern science gives viewers a multi-layered appreciation for the lights, both as a natural marvel and a cultural treasure. Fact 15. Medieval European beliefs. In medieval Europe, the Northern Lights inspired a mix of awe, curiosity, and sometimes fear. Without scientific understanding, many people interpreted the auroras as signs or warnings. Some chroniclers described the lights as heavenly fires or omens of change, and these accounts often coincided with other unusual events like comets or solar storms. Despite the mystical interpretations, Europeans also began to record auroral events systematically. Monks and scholars wrote about colour, movement, and timing, creating early logs that later helped scientists analyse auroral patterns. These historical records reveal an interesting duality. Humans were both frightened and fascinated, but they still sought to document what they saw. It's a reminder that even before satellites and space science, the Northern Lights had the power to inspire, challenge, and captivate people, just as they continue to do today. Fact 16. Early scientific studies. Once people started to take a closer look at the Northern Lights, science slowly began to replace myth and speculation. Early scientific studies were often carried out by astronomers and physicists who were fascinated by unusual light phenomena. They carefully observed auroras, recorded their frequency, direction, and colour, and tried to understand what caused these spectacular displays. One important realization was that the Northern Lights were not random. They appeared more often near the poles and were sometimes linked to solar activity. Early scientists measured patterns over years, noting how auroras shifted and changed with the seasons. These observations laid the foundation for our modern understanding of the aurora as a natural consequence of charged particles interacting with Earth's atmosphere. Even though their tools were primitive by today's standards, simple telescopes, rudimentary compasses, and handwritten logs, the dedication of these early researchers was remarkable. They braved long, cold nights in remote locations, often witnessing auroras in complete darkness for hours. Their careful documentation helped later scientists make connections between solar activity, geomagnetic storms, and the breathtaking lights we now enjoy. Fact 17. Benjamin Franklin and Aurora. Observations. Benjamin Franklin, best known for his experiments with electricity, also took an interest in the northern lights. While living in the 18th century, he observed unusual displays in the night sky and carefully noted the colours and movements. Franklin speculated about electrical forces at work, which was a remarkably forward-thinking idea for his time. He noticed that the aurora often coincided with geomagnetic activity, although he didn't have the tools to fully understand the connection. Franklin's observations were important because they helped establish a link between atmospheric electricity and auroral displays. His notes were later referenced by scientists studying the relationship between solar particles and Earth's magnetic field. What's interesting is that Franklin's approach combined curiosity and meticulous observation. He didn't jump to mystical explanations, instead, he sought natural causes. This scientific mindset helped pave the way for modern aurora research, demonstrating that even centuries ago, careful attention to the sky could reveal incredible insights about our world. Fact 18. 19th century polar expeditions. The 19th century was a golden era for polar exploration, and the Northern Lights played a starring role in many of these journeys. Explorers travelling to the Arctic and Antarctic frequently reported brilliant auroras, often describing them in diaries with awe and wonder. These expeditions weren't just about adventure, they contributed critical scientific data about auroral patterns. Expeditions often included naturalists and astronomers who meticulously recorded the light's frequency, shape, and colour. Observations from multiple locations allowed scientists to start mapping auroral ovals and recognise patterns related to solar activity. The data gathered during these harsh, often dangerous journeys were invaluable in advancing our understanding of the aurora. For the explorers themselves, the auroras were more than a subject of study. They were a source of inspiration during long, dark nights in the Arctic. The lights provided a sense of beauty and wonder in otherwise harsh, icy landscapes, reminding the travellers of the magic that still exists in the natural world. Fact 19. Famous Northern Lights. Diaries. Throughout history, many adventurers and scientists kept detailed diaries of auroral displays. These diaries are a treasure trove of information, combining personal experience with careful observation. Writers describe the colours, shapes, and movement of the lights, often capturing moments of awe, fear, or joy. One recurring theme in these diaries is the unpredictability of the aurora. Observers would describe nights of quiet, subtle glows, suddenly interrupted by explosive curtains of colour. Some diaries even note faint sounds, a phenomenon that modern scientists are still investigating. These personal accounts were crucial for early research. By comparing notes from different observers, scientists could identify patterns, track solar cycles, and make early predictions about auroral activity. The diaries also give us a window into the human side of aurora observation, the wonder, the patience, and the sheer fascination that has drawn people to the polar skies for centuries. Fact 20. First photographs of aurora. Capturing the northern lights on film was a challenge in the early days of photography. Long exposure times, sensitive equipment, and the remote, cold locations made photographing auroras a true feat. Yet, by the late 19th and early 20th centuries, photographers began successfully documenting these celestial displays. These early photos were groundbreaking. For the first time, scientists and the public could see the aurora not just as a fleeting memory, but as a tangible image. Photographs revealed details invisible to the naked eye, like subtle colour variations and complex structures within the aurora. The development of aurora photography also helped advance scientific understanding. By comparing images taken from different locations and times, researchers could track patterns, study movement, and even begin to forecast auroral activity. Beyond science, these photos inspired awe and fueled curiosity, making the northern lights accessible to people who might never see them in person. Fact 21. Role of charged particles. At the heart of the northern lights is a cosmic connection between the Sun and Earth. Solar winds constantly send streams of charged particles, electrons and protons, hurtling toward our planet. Most of the time, these particles pass by without incident, but when they meet Earth's magnetic field, things get spectacular. The magnetic field funnels the particles toward the polar regions. As they enter the upper atmosphere, these charged particles collide with gases like oxygen and nitrogen. Each collision transfers energy, exciting the atoms and causing them to emit light. Essentially, the aurora is nature's own fireworks display, powered by the tiniest building blocks of the universe. Different particles interact in different ways. Electrons are responsible for most of the light we see, creating the iconic greens and reds. Protons contribute to rarer red and purple hues, adding depth and variation to the display. Without these charged particles, the sky would remain dark and still. No dancing ribbons of colour, no shimmering curtains, nothing that makes aurora chasing so addictive. Even more fascinating is that the intensity and pattern of auroras are directly linked to the flow of these particles. A surge in solar wind can transform a faint glow into a massive shimmering spectacle that stretches across the sky. So next time you watch the aurora, remember, every flicker is a particle crash millions of kilometers in the making. Fact 22. Solar storms and geomagnetic activity. Sometimes the Sun doesn't just send a gentle stream of particles, it erupts with full-blown solar storms. These storms hurl enormous amounts of charged particles toward Earth, and when they collide with our magnetic field, the result can be a dramatic surge in auroral activity. Solar storms can intensify the aurora, creating brighter, more colourful and more widespread displays. These are the nights when even people hundreds of kilometres south of the Arctic can catch a glimpse of green, red or purple lights dancing overhead. The aurora becomes more dynamic, moving faster and forming unusual shapes like vertical rays or spiralling curtains. Geomagnetic activity is what scientists monitor to predict these events. Instruments measure fluctuations in the magnetic field caused by solar storms, providing early warning for aurora enthusiasts. It's fascinating to realize that something happening 150 million kilometers away on the Sun can directly influence the lights in our sky. In addition to creating spectacular visuals, strong geomagnetic storms can affect technology, satellites, power grids, and even radio signals. But for observers, it's a thrilling reminder of just how connected we are to the Sun. Those bright nights of northern lights, they're powered by the raw energy of a solar storm reaching our atmosphere. Fact 23. Aurora and the sunspot cycle. The northern lights don't happen randomly. They follow a pattern linked to the Sun's sunspot cycle, which lasts about 11 years. Sunspots are cooler, darker areas on the Sun's surface, but they are also hotspots for solar activity. When sunspots are numerous, the Sun produces more flares and solar wind, which means more charged particles heading toward Earth. During the peak of the sunspot cycle, auroras become more frequent and more vivid. Nights that might normally show only a faint glow can suddenly explode into ribbons of green, red and purple across the sky. Conversely, during solar minimum, auroras are less common and displays are often subtler. This cycle helps scientists predict auroral activity over long periods. By tracking sunspots, they can anticipate years with spectacular northern lights, making it easier for travellers and researchers to plan trips and studies. The sunspot cycle shows how even distant changes on the Sun can have a direct visible impact on our skies, a cosmic rhythm we can watch and enjoy. Fact 24. The physics of light emission. The northern lights are essentially a glowing response to collisions in the upper atmosphere, but the science behind light emission is fascinating. When charged particles collide with oxygen or nitrogen, they transfer energy to the atoms, exciting their electrons. When these electrons return to their normal state, they release energy in the form of light. Different atoms emit different wavelengths, which is why we see distinct colours. Oxygen emits green or red light depending on altitude, while nitrogen produces purples and blues. These emissions are not constant. They vary depending on particle energy, atmospheric density, and even magnetic field conditions. The flicker, shimmer, and movement we see aren't just aesthetic, They reflect rapid, complex interactions happening on a microscopic level. Each moment in the aurora is the cumulative effect of millions of these tiny collisions, producing a spectacle that's both scientifically precise and visually breathtaking. Understanding the physics helps explain why auroras appear in layers, waves, or curtains, and why no two displays are ever exactly the same. Even though the mechanics are intricate, the effect is simple, a natural light show that makes the night sky unforgettable. Fact 25. Why aurora colours vary. One of the most captivating aspects of the northern lights is the range of colours: greens, reds, purples, and sometimes blues. The secret lies in two main factors: the type of atmospheric gas and the altitude of the collision. Oxygen at lower altitudes, around 100 km, produces green, the most common aurora colour. Higher up, oxygen emits red light, which is rarer and often subtle. Nitrogen interacts differently, producing purple and blue hues depending on the energy of the collision. The combination of gas types, altitudes, and solar particle intensity creates the layered, multicoloured effects often captured in stunning photographs. Even the shape and movement of the aurora can affect perceived colour. Fast-moving curtains or ripples can mix hues, giving the sky a gradient effect. Slight differences in atmospheric conditions from one night to the next also alter colours, meaning no aurora show is ever identical. These variations are part of what makes aurora watching so mesmerising. You're not just seeing a single colour or pattern, you're witnessing a dynamic, living painting that's constantly changing in response to forces far beyond our planet. Fact 26. Why red auroras are rare. If you've ever seen a green aurora, you might wonder why red auroras are much rarer. The answer lies in altitude and oxygen behaviour. Red auroras occur at much higher altitudes, often above 200 kilometers, where oxygen atoms emit red light when excited by charged particles. At lower altitudes, collisions are more frequent, producing the familiar green glow instead. Red auroras also require specific solar conditions. Only when the solar wind is strong enough to push particles into the high-altitude regions do these deep red displays appear. This combination of factors, height, particle energy, and atmospheric density, makes red auroras a special treat for observers. They often appear faint, almost ghostly, compared to the vivid green that dominates most nights. Despite their rarity, red auroras are highly prized by aurora chasers and photographers. Seeing a deep red arc sweeping across the Arctic sky is a reminder of how dynamic and unpredictable the northern lights can be. It's nature's way of showing that even in a familiar phenomenon, there are surprises waiting for those patient enough to notice. Fact 27. The speed of aurora movements. One of the most mesmerizing things about the northern lights is how they move. Sometimes they drift slowly like floating curtains. Other times they ripple and shimmer with incredible speed. The movement is caused by variations in solar wind speed and fluctuations in the Earth's magnetic field. Charged particles spiral along magnetic lines, and changes in their energy or direction create waves that make the aurora dance. Strong geomagnetic storms can cause sudden bursts of light that move faster than the eye can track, giving the impression that the sky is alive. Even subtle variations in particle flow can create flickering effects, making the aurora appear to shimmer like silk in the wind. For aurora watchers, the speed and movement add drama. A slow, sweeping curtain can feel calming, while a fast, flickering display is thrilling, almost like watching a cosmic performance. Scientists use these movements to study interactions between solar particles and Earth's magnetosphere, turning every aurora into a natural laboratory. Fact 28. Magnetic poles shift. Effects. Earth's magnetic poles aren't fixed. They slowly shift over time, and this can influence where auroras appear. The auroral ovals, those zones around the poles where auroras are most visible, follow the magnetic poles rather than the geographic ones. So when the poles drift, the regions for optimal viewing shift too. This shifting explains why some places once famous for aurora sightings may see fewer displays over decades, while new locations suddenly become ideal. It's a slow, natural change, but it shows how connected auroras are to the invisible forces of the planet. Even small shifts in the magnetic field can alter the shape, location, and intensity of auroral displays. For scientists and aurora chasers alike, Tracking magnetic pole movements helps predict where and when the lights are most likely to appear. It's another layer of complexity that makes observing the northern lights both challenging and endlessly fascinating. Fact 29. Northern lights and radio interference auroras are beautiful, but they're also powerful enough to interfere with technology. The charged particles and geomagnetic activity that produce the lights can disturb radio signals, GPS systems, and even power grids in extreme cases. This happens because the energetic particles create fluctuations in Earth's magnetic field, which can induce currents and affect electromagnetic waves. Historically, radio operators noticed interference during strong auroral displays, long before satellites and modern communication systems existed. Today, scientists continue to study these effects to protect technology, while still appreciating the natural spectacle. It's a fascinating example of how something visually stunning can have practical implications on our daily lives. So, while you're enjoying the northern lights, know that the same invisible forces lighting up the sky are also influencing signals, wires, and instruments, reminding us that nature's beauty often comes with hidden power. Fact 30. Aurora in other planets. Earth isn't the only planet with auroras. Jupiter, Saturn, Uranus, and Neptune all display their own versions of auroral lights. On these planets, the auroras are shaped by much stronger magnetic fields and different atmospheric compositions. For example, Jupiter's auroras are driven not only by the Sun but also by particles from its volcanic moon. Auroras on other planets can be far more intense than those on Earth. Jupiter's auroras, for instance, are thousands of kilometers high and can emit ultraviolet light, invisible to the naked eye but stunning in images captured by telescopes. Studying these auroras helps scientists understand planetary magnetic fields and atmospheres, as well as the solar wind's impact across the solar system. Comparing auroras across planets also gives us perspective on Earth's northern lights. While ours are extraordinary, they're just one part of a vast cosmic phenomenon. Knowing that auroras exist elsewhere reminds us that the universe is full of light shows, waiting to be observed and understood. Fact 31. Best countries to see the lights. If you're dreaming of seeing the northern lights in person, choosing the right country is key. The best displays happen near the Arctic Circle, where the auroral ovals are most active. Countries like Norway, Sweden, Finland, Canada, Iceland, and Alaska in the United States consistently offer some of the most spectacular views. Each location has its own charm. Norway's fjords provide dramatic backdrops, while Finnish Lapland offers cozy cabins and clear winter skies. Canada's vast wilderness means minimal light pollution, perfect for photography. Iceland combines rugged landscapes with geothermal hot springs, giving visitors the chance to watch auroras reflected in steamy pools. Even Alaska, with its remote mountain ranges, provides unforgettable nights under vibrant skies. Timing and weather matter too. Winter months offer long, dark nights, increasing the chances of seeing a show. Clear skies are essential, as clouds can completely obscure the lights. Many travellers plan multi-night trips, knowing that patience is often rewarded with dazzling displays. For aurora enthusiasts, picking the right country is just the first step in an adventure that combines travel, patience, and awe-inspiring natural beauty. Wherever you go, the northern lights never fail to impress. Fact 32. Scandinavia's aurora. Hotspots. Scandinavia is a dream destination for aurora watchers. Norway, Sweden, and Finland each offer unique experiences under the northern lights. In Norway, Tromsø is a favourite, with mountains and fjords creating dramatic settings for auroral displays. Swedish Lapland offers remote locations like Abisko, known for its clear skies and high likelihood of sightings. Finnish Lapland provides cosy accommodations, where you can watch the aurora from glass igloos or traditional cabins. Scandinavia also benefits from minimal light pollution in rural areas. The long, dark winter nights provide ideal conditions for observing auroras. Travellers often combine aurora chasing with activities like dog sledding, snowshoeing, or visiting Sami villages, making the experience unforgettable. For photographers, Scandinavia's landscapes add an extra layer of beauty. Snow-covered forests, frozen lakes, and rugged mountains create perfect reflections and contrasts for capturing the aurora. Whether you're a casual traveller or a serious aurora chaser, Scandinavia offers some of the most reliable and breathtaking experiences on the planet. Fact 33. Canadian Aurora Zones Canada is another top destination for the Northern Lights. The country's vast northern regions, including Yukon, Northwest Territories, and Nunavut, are prime spots. Cities like Yellowknife and Whitehorse are famous for their frequent bright auroras. One advantage Canada has is the sheer size and remoteness of its northern wilderness, which minimises light pollution and provides uninterrupted views. Canadian auroras are often intense and colourful, stretching across the sky in waves and curtains. Winter is peak season, with long nights and crisp, cold air creating perfect viewing conditions. Many travellers choose to combine aurora watching with winter activities like ice fishing, dog sledding, or visiting Indigenous communities. For photographers, Canada offers unique opportunities. Snow-covered forests, frozen lakes, and wide-open skies create incredible compositions. Whether you're capturing subtle greens or dramatic red hues, Canada's northern regions provide an unforgettable backdrop for one of nature's most spectacular shows. Fact 34. Alaska and the Lights. Alaska is one of the most accessible places for seeing the Northern Lights in the United States. Fairbanks is a popular destination, offering frequent displays, clear skies, and amenities for travellers. The aurora often appears in dramatic arcs and waves, painting the sky with green, purple, and sometimes red hues. Alaska's remote landscapes, including mountains, rivers, and forests, enhance the experience. Many visitors combine aurora watching with winter sports, wildlife spotting, or exploring national parks. The long nights of winter provide excellent conditions, and aurora forecasting tools help travellers time their viewing for the most spectacular displays. What makes Alaska especially appealing is the combination of natural beauty, reliable auroral activity, and infrastructure for tourists. Even first-time aurora watchers can experience the magic without venturing too far off the beaten path, making Alaska a perfect mix of adventure and comfort. Fact 35. Iceland's spectacular displays. Iceland is famous for its otherworldly landscapes, and seeing the northern lights there is a surreal experience. The country's combination of volcanic terrain, glaciers, waterfalls, and geothermal hot springs creates unforgettable scenes. Imagine watching auroras reflected in a steaming pool or above a frozen waterfall, nature's own light show paired with Iceland's dramatic scenery. Popular viewing spots include Thingvellir National Park, Jökulsárlón Glacier Lagoon, and remote rural areas with minimal light pollution. Winter offers long, dark nights, giving photographers and travellers ample opportunity to witness the auroras. Iceland's relatively small size makes it easy to travel between different landscapes, increasing the chances of catching the perfect display. Aurora tours are popular, ranging from guided hikes to super jeep adventures. Many visitors combine aurora watching with other Icelandic experiences, like visiting geysers, black sand beaches, or geothermal spas. The combination of Iceland's natural beauty and the northern lights makes it one of the most memorable destinations in the world. Fact 36. Greenland observations. Greenland is one of the most pristine places to witness the northern lights. With vast, uninhabited landscapes and minimal light pollution, the auroras here appear in their full glory, often stretching across the sky from horizon to horizon. Observers report not only vibrant greens but also hints of reds and purples, especially during strong solar activity. The Arctic climate provides long, dark nights, perfect for viewing the lights. Travellers often combine aurora watching with icebergs, glaciers and fjords, creating a breathtaking natural backdrop. In Greenland, local guides share not only the science behind the auroras, but also traditional Inuit stories that describe the lights as dancing spirits in the sky. Patience is key in Greenland. Weather can change quickly, and clear skies are essential. Yet those who wait are rewarded with some of the most intense and beautiful auroral displays on Earth. For photographers, Greenland offers unique opportunities, capturing auroras over frozen fjords or reflecting in icy waters. Fact 37. Russia's Siberian Lights. Siberia in Russia is an extraordinary destination for Northern Lights enthusiasts. Its vast, sparsely populated regions stretching above the Arctic Circle provide almost uninterrupted darkness during winter months. This makes it an ideal place to observe auroras without light pollution interfering with the display. The auroras in Siberia can be incredibly bright and dramatic, often appearing as long curtains or waves of green and red across the horizon. Cities like Norilsk or small Arctic settlements offer vantage points, but the most breathtaking views are found deep in the wilderness, where the sky seems endless. Siberian aurora watchers often combine the experience with winter activities such as dog sledding, ice fishing, or exploring the tundra. The region's extreme climate adds a sense of adventure, as clear nights under the aurora are rare and treasured. For those who endure the cold, the Siberian northern lights are some of the most intense and memorable displays in the world. Fact 38. Viewing from Scotland and Ireland. While the northern lights are most common near the Arctic Circle, they can occasionally be seen much further south. Scotland and Ireland provide such opportunities, especially during strong solar storms. Though sightings are less frequent, when auroras appear, they are breathtaking against rugged coastlines and ancient landscapes. Northern Scotland, particularly the Highlands and islands like Shetland and Orkney, offers the best chances. Dark skies, minimal city light, and northern latitude make these locations ideal. In Ireland, the northern counties of Donegal and Antrim sometimes catch glimpses of faint green or red auroras. For residents and travellers, aurora sightings in these regions are special events. People often watch for months for the right conditions, including clear skies and geomagnetic activity. Seeing a northern light display this far south is a rare and memorable experience, reminding us that auroras are not strictly confined to polar regions. Fact 39. Optimal latitude for auroras are most frequently observed within the auroral ovals, which encircle the magnetic poles. This means the optimal latitude for aurora viewing is roughly between 65° and 72° north, though displays can occasionally be seen further south during strong solar storms. Staying within this range increases the likelihood of frequent and intense auroras. Countries like Norway, Finland, Sweden, and Canada fall squarely within this optimal zone. The closer you are to the centre of the auroral oval, the brighter and more active the auroras appear. Even slight shifts in latitude can make a difference in both frequency and intensity, so careful planning is essential for aurora chasers. The optimal latitude also depends on season and magnetic activity. During solar maximum, the auroral oval expands, increasing chances of sightings at lower latitudes. Conversely, during solar minimum, the oval contracts, making auroras rarer even within traditional high-latitude zones. Fact 40. Aurora visibility near cities versus wilderness. While the northern lights are naturally spectacular, light pollution can dramatically affect their visibility. Cities, even small ones, create enough artificial light to obscure subtle auroral colours. This is why the best sightings are almost always in remote wilderness areas. Travelling away from urban centres allows viewers to experience the full intensity and colour range of the aurora. In rural areas, you can see delicate purples and reds that might never appear over city skies. Snow and ice can enhance the effect by reflecting light, creating a magical mirrored display. For photographers, wilderness locations are crucial. Remote lakes, mountains, and tundra provide dark backgrounds that let the aurora stand out sharply in images. Even a short drive away from city lights can transform an ordinary night sky into a breathtaking natural show, proving that for the northern lights, isolation is part of the experience. Fact 41. Best time of year to see auroras. Timing is everything when it comes to seeing the northern lights. While they can occur year-round, winter months in the northern hemisphere provide the best opportunity. This is because nights are longer, skies are darker, and there's more contrast for the lights to appear vividly against the darkness. The period from late September to early April is generally considered prime aurora season. During these months, most of the Arctic and subarctic regions experience long nights, sometimes lasting 18 to 20 hours. This extended darkness increases the chance of witnessing a display, especially when combined with clear skies and minimal light pollution. Fall and early spring also offer good conditions. Although nights are shorter, auroras can still be strong during periods of high solar activity. Travellers often plan trips around these months, balancing daylight hours for outdoor activities with optimal conditions for aurora watching. Ultimately, the best time to see auroras depends on location, weather, and solar conditions. Planning a trip during peak winter ensures longer nights and a higher likelihood of catching the sky's magical performance. Fact 42. Solar maximum versus solar minimum effects. Aurora activity is closely tied to the Sun's 11-year sunspot cycle, which alternates between solar maximum and solar minimum. During a solar maximum, sunspots are more frequent, increasing the likelihood of solar storms that send charged particles toward Earth. This results in brighter, more frequent auroral displays, sometimes visible far south of the Arctic Circle. During solar minimum, auroras are less common and often weaker. Fewer sunspots mean fewer solar flares and a calmer solar wind, reducing the energy available to excite atmospheric particles. While auroras still occur, the displays are usually less vivid and more confined to higher latitudes. Aurora enthusiasts often plan trips around the solar cycle. Traveling during a solar maximum increases the odds of witnessing dramatic, multicolored displays. Even during solar minimum, however, patience and clear skies can still reward observers with stunning visuals. Understanding the solar cycle helps both casual viewers and scientists anticipate and study auroral activity effectively. Fact 43. Midnight sun versus polar night influence. In the Arctic, the extreme daylight patterns of midnight sun and polar night directly affect aurora visibility. During the midnight sun, which occurs in summer, the sun never fully sets. Continuous daylight makes it impossible to see auroras no matter how strong the solar activity. Conversely, the polar night in winter offers almost constant darkness, creating perfect conditions for aurora observation. Long uninterrupted nights allow the lights to appear for hours, often accompanied by dramatic shapes and vibrant colours. The contrast between dark skies and auroral displays is what makes the experience so mesmerising. For travellers, this means planning is essential. Visiting during periods of darkness maximises viewing opportunities, while summer trips might be better for exploring landscapes and other activities, rather than aurora watching. Nature's timing plays a crucial role in this cosmic performance. Fact 44. Aurora in different months. Auroras can vary in frequency and intensity throughout the year. In September and October, nights are long enough for good visibility, and solar activity often picks up after summer. November through February offers the longest nights, and often the clearest skies, making these months ideal for intense displays. March and early April continue to provide good viewing, with long nights and cold, crisp air that enhances visibility. Spring auroras are often accompanied by vibrant colours, thanks to solar activity during the preceding months. Summer months, with the midnight sun, are generally unsuitable for aurora viewing, except at extreme latitudes where darkness might still occur for brief periods. Understanding these monthly variations helps observers plan trips strategically, increasing the chances of experiencing the sky's full range of colours, shapes, and intensity. Patience and timing combine to make each aurora season unique. Fact 45. Winter nights and darkness. Winter is truly the season of the northern lights. Long nights, often stretching up to 20 hours above the Arctic Circle, create perfect conditions for observation. The darkness allows even faint auroras to become visible, transforming the sky into a dynamic canvas of colour. Cold winter air often comes with clear skies, reducing haze and moisture that could obscure the lights. Snow-covered landscapes enhance the visual impact by reflecting auroral colours, creating breathtaking scenes. Many travellers combine aurora watching with winter activities like dog sledding, ice fishing, or visiting remote cabins, making the experience both magical and memorable. Patience is essential in winter, as weather conditions can change rapidly. But for those willing to wait, the long nights provide some of the most intense and vivid auroral displays of the year. Winter darkness is not just an absence of light, it's the stage on which the northern lights shine their brightest. Fact 46. Aurora forecasts. For modern aurora watchers, forecasting tools have transformed the experience. Scientists use data from satellites, solar observatories, and geomagnetic monitoring stations to predict auroral activity. These forecasts estimate the likelihood, intensity, and location of northern lights displays, giving observers a better chance of witnessing the spectacle. Forecasts often include a scale, showing the probability of auroras at various latitudes. They consider factors like solar wind speed, geomagnetic storms, and solar flares. Websites and mobile apps provide real-time updates, making it easier for travellers and enthusiasts to plan viewing trips or spontaneous nighttime excursions. While forecasts are incredibly useful, they are not guarantees. Weather conditions, cloud cover, and local light pollution still play a role. Yet, even a moderate forecast increases the chance of a memorable display, helping observers time their trips for maximum aurora impact. Forecasting turns the northern lights from a lucky sighting into a more predictable adventure. Fact 47. Moonlight and its impact on viewing. The brightness of the moon can significantly affect aurora visibility. A full moon casts enough light to reduce the contrast between the aurora and the night sky, making fainter displays harder to see. Conversely, a new moon or crescent phase allows the aurora's colours to shine vividly against the dark backdrop. Moonlight can also influence photography. While a full moon can illuminate landscapes beautifully, it may wash out subtle auroral hues. Photographers often plan shoots around moon phases to capture the most vibrant greens, reds, and purples. In some cases, combining moonlight with auroras creates stunning, ethereal images with both sky and landscape visible. For casual viewers, moonlight isn't a deal-breaker. Bright auroras during strong solar activity can still overpower moonlight, but for subtle displays, darker nights make a significant difference. Timing aurora viewing around the lunar cycle can enhance the experience, whether for observation or photography. Fact 48. Daylight hours and aurora visibility. Aurora viewing is all about nighttime. During periods of extended daylight, like the Arctic summer, the sky remains too bright to see auroras, even during strong solar storms. Conversely, long winter nights provide the perfect canvas for the lights to appear. The hours of darkness directly affect both frequency and duration of auroral sightings. In high-latitude regions, nights can last 18 to 20 hours in midwinter, offering extended opportunities to observe and photograph the phenomenon. Short nights during transitional seasons limit viewing time, making patience and careful timing crucial. Understanding daylight hours is particularly important for planning trips. Travellers who want the best chance of seeing the aurora must align their visit with the darkest months, when nightfall comes early and lingers long into the morning. Fact 49. Long-term trends in aurora. Activity. Auroras aren't constant. Their activity fluctuates over years, decades, and centuries. Scientists study long-term trends using historical records, satellite data, and even ice core samples. These trends reveal how solar cycles, geomagnetic shifts, and climate variations influence auroral activity. Historical accounts show periods of intense auroral activity followed by quieter decades. Modern observations, aided by satellites, provide precise measurements of auroral frequency, intensity, and geographic reach. Studying these trends helps scientists predict future aurora behavior and understand the broader relationship between solar activity and Earth's magnetic field. For aurora enthusiasts, long-term trends explain why some years produce spectacular displays while others are less impressive. They also highlight the dynamic, ever-changing nature of our planet's interaction with the Sun. Fact 50. Aurora cycles. Over centuries beyond yearly solar cycles, auroras also follow century-scale patterns. Researchers use historical observations from explorers, ship logs, and diaries, combined with modern scientific measurements, to map auroral activity over hundreds of years. These long-term cycles reveal periods when auroras were frequently visible at lower latitudes, and other times when they were largely confined to the Arctic. Such patterns correlate with variations in solar activity, like grand solar minima and maxima, showing the Sun's influence on Earth over centuries. Understanding these cycles allows scientists to place current auroral activity in a historical context. For observers, it's fascinating to realize that the northern lights they see today are part of a story that stretches back generations, a cosmic phenomenon that has thrilled humans for centuries and will continue to do so for centuries to come. Fact 51. Legends of spirits and ghosts. Throughout history, people have often linked the northern lights to spirits and supernatural phenomena. In many cultures, the shimmering curtains and dancing ribbons were thought to be the activity of spirits wandering the skies. For some Arctic communities, the aurora was seen as the souls of ancestors, or the presence of otherworldly beings. These interpretations weren't about worship, but about storytelling, explaining a mysterious and awe-inspiring natural phenomenon in ways that made sense before science could provide answers. People described the lights as flickering figures, sometimes moving in patterns or appearing to dance, which fit perfectly with tales of spirits moving across the heavens. Even today, these stories add to the magic of the aurora. Travellers hearing local legends often report feeling a deeper connection to the night sky, as though the lights carry echoes of centuries of human imagination. The northern lights have always inspired wonder, blending natural beauty with the richness of folklore. Fact 52. Aurora, as an omen in different cultures. In addition to spirits, the aurora was often considered an omen. In some Arctic regions, unusual displays were interpreted as warnings of storms, harsh winters, or important events. Sailors and hunters paid close attention, believing the intensity and colour of the lights could signal danger or opportunity. In medieval Europe, faint green or red auroras were sometimes seen as signs of change, whether in the weather, the environment, or human affairs. Observers would take careful note of the sky, creating detailed records that sometimes blended observation with superstition. These interpretations show how humans have always sought meaning in the patterns of nature, turning a scientific phenomenon into a guide for daily life. Auroras as omens demonstrate the human instinct to connect natural phenomena with everyday life. Even now, these ideas add a cultural layer to the scientific understanding, reminding us that the lights have inspired both practical observation and imaginative storytelling across generations. Fact 53. Sami people stories. The Sami people of northern Scandinavia have a rich history of aurora stories. For them, the lights were powerful and fascinating, often treated with respect and caution. Some stories describe the aurora as a living force that could interact with humans, reflecting their behaviour or mood. Children were sometimes warned not to wave at the lights or whistle at them, as the aurora might respond or play tricks. These tales weren't about fear, but about teaching respect for nature. The lights were seen as beautiful but potentially dangerous if disrespected, reinforcing the Sami connection to the environment. Sami legends add a layer of cultural richness to the aurora experience. Observers today can appreciate both the science and the stories, knowing that the lights have been a source of wonder, guidance, and inspiration for indigenous communities for centuries. Fact 54. Japanese aurora beliefs. In Japan, auroras have a unique interpretation tied to luck and family. Some traditional beliefs suggested that children conceived under the northern lights would be particularly blessed or fortunate. The aurora was associated with beauty and rare opportunity, a fleeting moment that could bring good fortune if experienced thoughtfully. Japanese stories often focus on the ethereal quality of the lights, their fleeting nature, their colours, and their movement across the sky. These tales show a cultural appreciation for natural phenomena, blending observation with poetic imagination. Even today, the idea of auroras as symbols of luck adds charm and a sense of wonder for viewers. Fact 55. Aurora in modern art. The northern lights continue to inspire modern art in paintings, photography, music, and even digital media. Artists try to capture the light's vibrant colours, flowing shapes, and dynamic movements, translating a natural spectacle into creative expression. From realistic landscapes showing the aurora over snowy forests to abstract interpretations emphasizing motion and colour, the lights provide endless inspiration. Photographers use long exposures to reveal details invisible to the naked eye, while painters experiment with textures to mimic shimmering waves and curtains. Modern art allows people to experience auroras in new ways, even if they can't travel to the Arctic. It celebrates the beauty, movement, and mystery of the lights, bridging the gap between science, culture, and imagination. The northern lights remain a muse, proving that some natural phenomena are timeless sources of wonder. Fact 56. Songs inspired by northern lights. The northern lights have inspired countless songs and musical compositions across cultures. Musicians often describe the aurora in terms of movement, colour, and emotion, translating the visual spectacle into sound. From folk tunes in Scandinavia to contemporary instrumental pieces, the lights have been a muse for centuries. Some songs attempt to capture the aurora's flowing movement, with melodies that rise and fall like curtains of light in the sky. Others focus on the emotional impact, wonder, or even solitude experienced under the Arctic night. Traditional communities such as the Sami have incorporated the lights into chants and stories, turning observations of the sky into rhythm and melody. Even modern artists continue this tradition. Ambient music, electronic compositions, and orchestral pieces often use the aurora as inspiration for pacing, tone, and texture. Music gives the aurora a new dimension, allowing people to experience its beauty not just visually but emotionally, through sound. Fact 57. Aurora in literature. Auroras have appeared in literature as symbols of mystery, beauty, and nature's power. From travel journals by early explorers to contemporary novels, writers have described the lights with vivid imagery, comparing them to dancing spirits, curtains of fire, or shimmering waterfalls in the sky. In many works, auroras evoke a sense of awe and wonder, often tied to personal reflection or adventure. Descriptions focus on movement, colour, and unpredictability, conveying the emotional experience of witnessing the lights firsthand. Poets, in particular, have used the aurora to explore themes of transience and change, highlighting the fleeting beauty of these natural displays. Literature helps bring the aurora to audiences far from the Arctic. Even without travelling to northern latitudes, readers can imagine the shifting lights, connecting science and storytelling in a way that inspires curiosity and admiration. Fact 58. Aurora in film and photography. Film and photography have made the northern lights accessible to a global audience. Filmmakers use long exposures and cinematic techniques to capture the motion and colours of auroras, while photographers experiment with settings, composition, and timing to reveal the light's full beauty. Documentaries often include auroras to illustrate Arctic environments or scientific phenomena, while fiction films use them as dramatic backdrops for emotional or adventurous scenes. In photography, techniques such as time-lapse allow viewers to witness movement and transformation over several hours in just a few minutes. Modern technology also enables high-resolution captures, revealing subtle colours and patterns invisible to the naked eye. Whether on film or in photographs, auroras continue to inspire artists to explore the intersection of science and visual storytelling. Fact 59. Tourism. Myths about auroras. Tourism around the Northern Lights has given rise to myths and misconceptions. Some travellers believe that the lights can appear on demand, or that the brightest displays are guaranteed every night. In reality, auroras are influenced by solar activity, weather, and geographic location, making them unpredictable. Another common myth is that auroras can be seen vividly from major cities. Light pollution often obscures colours, meaning remote areas offer the best visibility. Some tourists also assume that auroras are purely green, while in reality red, purple, and blue hues appear depending on altitude, gas composition, and particle energy. Understanding these myths helps travellers set realistic expectations and plan better aurora viewing trips. The unpredictability is part of the experience. The anticipation of a rare magical display is what makes witnessing the lights so memorable. Fact 60. Festivals celebrating aurora. Several Arctic regions celebrate the Northern Lights through festivals and events, combining science, culture, and tourism. In Norway, Sweden, Finland, and Canada, festivals include aurora-themed activities, photography workshops, and guided night tours, often paired with local music, cuisine, and crafts. These festivals allow visitors to experience the aurora in multiple ways, through observation, education, and cultural immersion. Some events highlight indigenous stories about the lights, while others focus on scientific explanations and interactive experiences. They bring communities and travellers together under the same magical sky, celebrating a natural phenomenon that transcends borders. Aurora festivals also boost awareness of environmental preservation. Participants learn about the delicate conditions needed to see the lights, including dark skies and minimal light pollution, encouraging respect for nature while celebrating its beauty. Fact 61. How to photograph the Northern Lights. Photographing the Northern Lights is a combination of preparation, technique, and patience. Unlike daytime photography, aurora photography requires dealing with low light, moving colours, and sometimes extreme cold. The first step is finding a dark location, away from city lights, where the sky is clear. Snow-covered landscapes or open fields often enhance the visual impact by reflecting the aurora's colours. Tripods are essential for stability, as long exposures are needed to capture the faint lights. Using a wide-angle lens allows you to frame the sky and landscape together, creating dramatic compositions. Observers should arrive early to scout locations, set up equipment, and adjust settings before the aurora appears. Patience is crucial. The aurora can appear suddenly, disappear, or change intensity within minutes. By understanding basic techniques and being prepared, photographers increase their chances of capturing breathtaking images that reflect both the beauty and movement of the northern lights. Fact 62. Camera settings for aurora shots. To photograph auroras effectively, specific camera settings are key. Start with a wide aperture, f2.8 or lower, to let in as much light as possible. ISO should be set between 800 and 3200, depending on the camera's sensitivity and the brightness of the aurora. A longer shutter speed, often between 5 and 30 seconds, allows enough light to reach the sensor while capturing the motion of the aurora. Focus manually on distant stars or the horizon to ensure sharpness, as autofocus can struggle in low-light conditions. White balance settings can be adjusted to highlight the natural green, red, or purple hues. Using a remote shutter release or timer helps prevent camera shake, which is especially important during long exposures. Experimentation is part of the process. Every aurora display is different, and light conditions can change rapidly. Adjusting settings on the spot allows photographers to capture the full range of colours and movement in real time. Fact 63. Long exposure techniques. Long exposure photography is the secret to capturing auroras in all their glory. By keeping the camera's shutter open for several seconds or even minutes, you can record the faint light of the aurora that the human eye might not fully perceive. This technique also emphasizes motion, creating flowing, ribbon-like effects across the sky. Using a sturdy tripod is essential, as any movement blurs the image. A remote shutter or intervalometer prevents vibrations when pressing the shutter button. Photographers also experiment with different exposure times. Shorter exposures capture sharp aurora details, while longer ones create ethereal, sweeping patterns. Long exposure not only captures the aurora's color and movement, but also highlights foreground elements like trees, mountains, or snow-covered landscapes. It transforms the scene into a dynamic, almost surreal image, showing the northern lights in ways impossible to see with the naked eye. Fact 64. Common mistakes in aurora photography. Even experienced photographers can make mistakes when capturing auroras. One common error is using too high an ISO, which can introduce excessive noise and reduce image quality. Another is poor focus. Autofocus often struggles in low light, so manual focus on stars or distant lights is essential. Overexposure can wash out colors, while underexposure may make the aurora barely visible. Shaky tripods or pressing the shutter without a remote release can blur the image. Finally, ignoring foreground composition can result in beautiful skies with a dull or distracting landscape. Avoiding these mistakes requires preparation, knowledge of camera settings, and careful observation. By paying attention to detail and adjusting for conditions, photographers can capture auroras in their full beauty, producing images that reflect both the magic and science of the lights. Fact 65. Smartphone versus professional cameras. Modern smartphones can capture auroras in certain conditions, but professional cameras usually produce better results. Smartphones have small sensors, limiting low-light performance, though some models offer night modes that improve results. DSLRs and mirrorless cameras with manual settings, wide aperture lenses, and long exposure capabilities provide more control. They can capture subtle colors, motion, and high-resolution details that smartphones may struggle with. Using a tripod and remote shutter enhances both types of cameras, but professional equipment gives more flexibility for experimentation. That said, smartphones are convenient for casual observers or quick captures. They allow instant sharing of aurora sightings, though enthusiasts seeking professional quality images typically rely on specialized cameras for the full range of color, movement, and clarity. Fact 66. Best locations for nighttime photography. Capturing the northern lights requires finding the perfect location, where dark skies meet striking landscapes. Remote areas far from city lights are ideal, as light pollution can wash out even the brightest auroras. High-latitude regions like northern Norway, Finnish Lapland, Canada's Yukon, and Alaska provide both darkness and dramatic scenery for photography. Natural features like mountains, lakes, fjords, and snow-covered forests enhance the visual impact. Snow reflects aurora colours, while water can create beautiful mirrored effects. Observers often scout locations in advance to identify strong foreground elements, which turn simple sky shots into striking compositions. Timing is also crucial. Arriving before sunset allows photographers to set up and capture twilight transitions, which can add depth to aurora shots. Combining location, timing, and landscape results in unforgettable images that highlight both the sky and Earth's beauty under the northern lights. Fact 67. Time-lapse techniques. Time-lapse photography is a popular way to capture the dynamic motion of auroras. By taking a series of images at regular intervals and combining them into a video, photographers reveal patterns and movements invisible to the naked eye. Curtains of light ripple across the sky, waves of colour dance, and shifts in intensity become visible over minutes or hours. A stable tripod and remote shutter are essential to prevent camera shake. Intervalometers or in-camera time-lapse modes automate shooting at consistent intervals, ensuring smooth final videos. Photographers often experiment with exposure times, ISO, and white balance to balance motion clarity and colour vibrancy. Time-lapse videos allow viewers to experience the aurora in a compressed timeline, highlighting the beauty and fluidity of this natural phenomenon. They turn a fleeting moment into a visual story that's both mesmerizing and educational. Fact 68. Aurora chasing tours. For travelers wanting a higher chance of seeing the aurora, guided aurora tours are an excellent option. Experts lead small groups to prime viewing locations, provide knowledge about the science and folklore of the Northern Lights, and ensure safety in harsh winter conditions. Tours often include transportation to areas with minimal light pollution, hot drinks and shelters for comfort, and guidance on photography techniques. Guides monitor aurora forecasts and weather conditions, maximizing the likelihood of a successful sighting. Some tours even offer overnight trips, allowing travelers to experience auroras at their peak without rushing. Aurora chasing tours combine adventure, education, and convenience. They allow both novice and experienced observers to enjoy the Northern Lights fully, with less worry about logistics or missing the display entirely. Fact 69. Apps for aurora alerts. Modern technology makes aurora observation easier with apps that provide real-time alerts. These apps track solar activity, geomagnetic storms, and local conditions, notifying users when auroras are likely visible in their area. Some apps even include maps showing auroral ovals and cloud cover predictions. By using alerts, observers can plan trips on short notice, travel to optimal locations, and adjust timing to catch the best displays. Many apps also provide educational content, helping users understand aurora science while tracking their appearance. These tools have revolutionized aurora watching. No longer limited to luck or guesswork, enthusiasts can combine planning, technology, and observation to enjoy the lights more consistently and efficiently. Fact 70. Safety tips while chasing. Auroras. Chasing the Northern Lights often means venturing into cold, remote, and dark environments, so safety is critical. Dress in layers with insulated, waterproof clothing, and wear hats, gloves, and thermal footwear to avoid frostbite. Always carry emergency supplies such as food, water, and a first aid kit. Travel in groups or inform someone of your location, especially in areas with limited cell coverage. Be cautious of icy roads, wildlife, and uneven terrain while moving at night. Proper lighting and reflective gear improve visibility and reduce the risk of accidents. Understanding and respecting local conditions ensures that aurora hunting remains a magical and safe experience. Planning ahead, monitoring weather, and prioritizing safety allow observers to focus on the beauty of the lights without unnecessary risk. Fact 71. Satellites. Observing aurora, satellites play a vital role in studying the Northern Lights. Orbiting above Earth, they provide a bird's-eye view of auroras, capturing patterns and movements invisible from the ground. These satellites measure solar wind particles, geomagnetic activity, and charged particle interactions that cause the lights, helping scientists understand the complex processes behind the aurora. One advantage of satellites is their ability to monitor auroras continuously over large areas. Ground observers might see only part of a display, but satellites track auroras across continents and oceans. Instruments on board can detect ultraviolet and X-ray emissions, giving insights into atmospheric processes and the energy involved in auroral displays. Data from satellites also helps forecast auroras, improving predictions for both scientists and enthusiasts. These observations bridge the gap between theory and reality, showing the aurora as a dynamic global phenomenon influenced by solar activity and Earth's magnetic field. Fact 72. Ground-based observatories. Ground-based observatories provide detailed, long-term observations of auroras from fixed locations. These stations, often located in high-latitude regions, use specialized cameras, spectrometers, and magnetometers to monitor the intensity, color, and movement of the lights. Observatories complement satellite data by offering high-resolution measurements of auroral activity. They track patterns over months and years, helping researchers study the relationship between solar cycles and geomagnetic storms. Some observatories allow public access, providing real-time aurora images and educational programs. By combining satellite and ground-based data, scientists gain a complete picture of how auroras form, evolve, and interact with Earth's atmosphere. Observatories also help train future researchers and keep enthusiasts connected to the ongoing study of these mesmerizing lights. Fact 73. Studying aurora with drones. Drones are becoming a modern tool for aurora research, offering flexibility that satellites and observatories cannot. Equipped with cameras and sensors, drones can fly beneath auroral displays, capturing unique angles and measuring atmospheric conditions at different altitudes. Drones are especially useful for observing auroras over remote or hazardous areas where ground access is limited. They provide data on temperature, air density, and magnetic fluctuations, complementing traditional observations. In addition, drones allow photographers and filmmakers to record auroras from new perspectives, creating dramatic visuals that enhance both science and art. This technology is still evolving, but drones are proving to be a valuable tool in aurora research, bridging gaps between ground observations and satellite data, and revealing details about the light's behavior that were previously inaccessible. Fact 74. Measuring magnetic storms. Auroras are closely tied to magnetic storms, caused by disturbances in Earth's magnetic field from solar activity. Scientists measure these storms using ground magnetometers, satellites, and other instruments to understand how charged particles interact with our planet's magnetosphere. Magnetic storms influence the brightness, color, and movement of auroras. Strong storms can push auroral displays further south, making them visible in locations that rarely see the lights. By tracking these storms, researchers can predict aurora intensity and provide forecasts for observers. Studying magnetic storms also has practical benefits. Understanding geomagnetic activity helps protect satellites, power grids, and communication systems from solar-induced disruptions. The science behind magnetic storms highlights the connection between auroras and the broader space environment surrounding Earth. Fact 75. Aurora and climate change. While auroras are primarily driven by solar activity, climate change can indirectly affect how we experience them. Changes in temperature, cloud cover, and atmospheric composition can influence visibility. For example, warmer Arctic winters may increase cloudiness, reducing clear nights for aurora observation. Long-term shifts in the atmosphere can also alter the distribution of particles in the upper layers, subtly affecting auroral colors and intensity. Scientists monitor these trends to understand both auroral patterns and the broader environmental changes occurring in high-latitude regions. Auroras remain a constant reminder of the dynamic relationship between Earth and the Sun. While climate change may impact our ability to see the lights as often or as clearly, the phenomenon itself continues, demonstrating the resilience and complexity of Earth's natural systems. Fact 76. Aurora and solar flares. Solar flares are intense bursts of energy from the Sun that send streams of charged particles hurtling toward Earth. When these particles reach our planet, they interact with the magnetic field and upper atmosphere, creating some of the most vivid and active auroras. The connection between solar flares and auroras means that stronger flares often produce brighter and more widespread displays. During major solar storms, auroras can appear far south of their usual Arctic latitudes, sometimes visible in areas that rarely experience them. Scientists monitor solar activity closely to understand these effects and provide forecasts for observers. Auroras caused by solar flares are often dramatic, with rapidly moving ribbons, intense colours, and large-scale coverage of the sky. Experiencing a solar flare-driven aurora is not just a visual spectacle, it's a live demonstration of the sun's influence on Earth's magnetic environment. Fact 77. Predicting aurora. Events. Predicting when and where auroras will appear involves analysing solar wind, geomagnetic activity, and magnetic storm data. Satellites provide real-time measurements of charged particles from the sun, while ground stations track magnetic field disturbances. Combining these datasets allows scientists to estimate aurora intensity, location, and timing. Apps and online platforms use these predictions to alert enthusiasts when conditions are favourable. While forecasts cannot guarantee sightings, clouds and local weather still play a role. They significantly increase the chances of experiencing a display. Advanced modelling and artificial intelligence are also being used to improve accuracy, giving both casual viewers and professional researchers better insight into aurora behaviour. Accurate prediction transforms aurora watching from a matter of luck into a planned activity, allowing observers to maximise opportunities for observation and photography. Fact 78. Research on aurora sound phenomena. Some observers report hearing sounds during aurora displays, described as faint crackles, hisses, or swishes. While this phenomenon is not fully understood, recent research suggests it may result from electrical disturbances in the lower atmosphere caused by charged particles. Scientists study these sounds using sensitive microphones and field experiments in Arctic regions. They are investigating whether the sounds are directly linked to auroras or are caused by secondary effects, such as temperature inversions amplifying distant noises. Aurora sounds remain rare, subtle, and difficult to document, but they add an additional sensory dimension to the experience. For observers fortunate enough to hear them, these noises deepen the sense of awe and connection to the natural phenomenon. Fact 79. Linking aurora to GPS disruptions. Auroras are more than a visual spectacle. They can interfere with modern technology. Charged particles from solar activity can disrupt the ionosphere, affecting radio signals, GPS systems, and satellite communications. During strong auroral events, navigation and communication equipment may experience temporary inaccuracies or signal loss. Scientists monitor auroras not only for their beauty but also for their impact on infrastructure. Forecasts of geomagnetic storms help airlines, shipping companies, and satellite operators prepare for potential disruptions. Understanding this link highlights the Northern Lights' role as both a natural wonder and a reminder of the Sun-Earth connection that affects daily technology. Fact 80. The role of amateur scientists. Amateur scientists play a significant role in aurora observation and research. Enthusiasts around the world track auroral activity, submit photographs, and report sightings, contributing valuable data to research databases. This citizen science helps fill gaps in coverage, especially in remote areas where professional observatories may not be present. Many online platforms allow amateurs to share aurora reports in real time, creating a global network of observers. These contributions help scientists study auroral patterns, track geomagnetic storms, and improve forecasting models. By participating, amateurs not only enjoy a personal connection to the Northern Lights, but also contribute to the global understanding of one of nature's most stunning phenomena. Their observations ensure that the study of auroras continues to expand, bridging the gap between curiosity and scientific knowledge. Fact 81. Famous aurora sightings in history. Throughout history, the Northern Lights have captivated observers and inspired awe. Some sightings were so intense that they were recorded in historical journals, ship logs, and personal diaries. For example, European explorers in the 17th and 18th centuries often described auroras as dancing flames or rivers of fire across the sky, sometimes bright enough to cast shadows on the ground. One notable event occurred in 1770, when intense auroras were visible across Europe, even as far south as Spain and Italy. Such sightings amazed populations that had never seen these lights, sparking curiosity, fear, and a rush to document the phenomenon. These historical observations provide valuable data for modern scientists studying long-term auroral trends and solar activity. Famous sightings also appear in literature, travel accounts, and indigenous oral traditions, preserving the human fascination with these luminous displays. They remind us that the northern lights have always been a source of wonder, bridging the past with the present in a shared experience of the sky. Fact 82. The longest recorded aurora event. The northern lights can sometimes persist for extended periods during intense solar activity. The longest recorded aurora event lasted several days, during which the sky was continuously illuminated with shifting colours and ribbons of light. Such prolonged displays often coincide with major geomagnetic storms and high solar wind activity. Observers during these events described unusual levels of brightness, rapid movement, and striking colour variations, with greens, reds, and even faint purples filling the night sky. Extended auroral events provide a rare opportunity for researchers to study the dynamics of the magnetosphere over longer timescales, revealing patterns that shorter displays cannot. For witnesses, prolonged auroras are a memorable and almost surreal experience, as the sky seems alive with motion and colour for hours or even nights on end. These rare events highlight the unpredictable and awe-inspiring nature of the northern lights. Fact 83. Aurora seen. During solar storms amplify auroral activity dramatically. When powerful solar flares and coronal mass ejections hit Earth's magnetic field, the result can be spectacular auroras visible far beyond typical polar regions. During these events, lights can appear in cities that rarely see them, thrilling observers unaccustomed to the display. Reports from major solar storms, such as the Carrington event in 1859, describe auroras so bright that people could read newspapers by their light at night. Such events are reminders of the intimate connection between solar activity and auroral intensity. While rare, solar storm-driven auroras showcase the full scale and energy of these natural phenomena, leaving a lasting impression on anyone fortunate enough to witness them. Fact 84. Aurora. During space travel, auroras are not limited to Earth's surface. They are visible from space. Astronauts aboard the International Space Station and other spacecraft have captured images of auroras from orbit, showing the lights as arcs and curtains encircling polar regions. From above, auroras appear as glowing, circular bands around the magnetic poles, offering a unique perspective on their shape and extent. These observations help scientists understand auroral patterns on a global scale, providing context that ground-based views cannot fully reveal. Seeing auroras from space emphasizes the connection between the Earth's magnetic field, solar activity, and the upper atmosphere, turning the phenomenon into a cosmic spectacle. Fact 85. Aurora in pop culture references. The Northern Lights have inspired countless references in popular culture, from films and TV shows to books, music, and video games. Filmmakers often use auroras as dramatic backdrops, emphasizing mystery, romance, or adventure. Animated films and fantasy worlds depict auroras as magical or symbolic, while musicians create compositions meant to capture the aurora's flowing colors and motion. Auroras also appear in advertising, tourism campaigns, and even video games, where they set an immersive and visually stunning environment. Pop culture references continue to amplify the public's fascination with the lights, making them one of the most recognizable natural phenomena worldwide. The blending of art, storytelling, and science ensures that the Northern Lights remain not just a scientific marvel, but also a cultural and emotional icon that captivates people across generations. Fact 86. Aurora as a meditation experience. Many people describe witnessing the Northern Lights as a meditative experience. The slow, flowing movements of the lights, combined with the stillness of a dark Arctic night, create a sense of calm and introspection. Observers often report feeling a connection to nature, a quiet focus, and even a sense of timelessness while watching the aurora. Meditation under the aurora can enhance mindfulness practices. The shifting colours and shapes provide a visual anchor, allowing observers to center themselves and remain present in the moment. For some, the experience becomes almost spiritual, not in a religious sense, but in the sense of deep personal reflection and awe at the natural world. This meditative aspect of aurora viewing adds a mental and emotional dimension to the spectacle. Beyond photography or scientific observation, simply sitting under the lights and observing their subtle dance can be a restorative and memorable experience. Fact 87. Impact on local wildlife. The northern lights, while beautiful for humans, can have subtle effects on local wildlife. Animals in high-latitude regions such as reindeer, birds and marine species are adapted to long periods of darkness and light. Sudden bright auroras can briefly alter behavior patterns, such as movement, hunting, or feeding activity. Migratory birds may navigate using geomagnetic cues, so strong auroral activity could potentially influence their orientation. Marine animals sensitive to light may also respond to unusually bright displays. However, these effects are generally temporary and minor, as most wildlife has evolved to tolerate occasional auroral activity. Understanding these interactions helps scientists appreciate the broader ecological context of auroras and ensures that human aurora watching activities minimize disruption to native species. Fact 88. Aurora reflections in water. One of the most striking aspects of aurora viewing is seeing the lights reflected in water. Lakes, rivers and fjords in high-latitude regions can mirror the aurora, doubling the visual impact and creating symmetrical, dreamlike scenes. Snow and ice can also act as reflective surfaces, enhancing colours and movement. Photographers and travellers often seek out locations with water to capture this effect, using long exposures to emphasise motion and depth. Reflections add a sense of tranquility and amplify the ethereal quality of the lights, making the landscape itself a part of the auroral display. Whether for photography or simple appreciation, watching auroras reflected in water adds a layer of beauty and visual drama, making the experience even more immersive. Fact 89. Seeing aurora from airplanes. Auroras are sometimes visible from airplanes, offering a unique perspective high above the clouds. From altitude, the lights appear more widespread and can stretch across the horizon in expansive, curved shapes. Window reflections and dark skies enhance the experience, allowing travellers to see patterns that might not be visible from the ground. Commercial flights over high-latitude routes, especially between North America and Scandinavia, occasionally pass beneath auroral displays. Pilots and passengers alike report awe-inspiring views of curtains, waves and arcs of light. Seeing auroras from the air emphasizes their global scale and dynamic nature, providing a brief yet unforgettable vantage point. Fact 90. Aurora and extreme sports. In some Arctic regions, people combine extreme sports with aurora viewing. Skiers, snowboarders, snowmobilers, and ice climbers often experience the lights during nighttime or early morning adventures, adding an extra thrill to already challenging activities. Auroras create a dramatic backdrop, turning ordinary sporting experiences into extraordinary visual events. Night skiing or snowmobiling under vibrant auroras adds a sense of excitement, beauty, and uniqueness. Guides ensure safety while providing opportunities to pause, appreciate, and photograph the lights. This combination of adrenaline and natural beauty makes aurora-inspired extreme sports both memorable and rare, showing that the northern lights can enhance not just observation, but adventure. Fact 91. Aurora in different wavelengths. When we see the northern lights, our eyes usually catch green, red, and sometimes purple hues, but the aurora's light extends far beyond what humans can perceive. In reality, auroras emit across a broad spectrum of electromagnetic wavelengths, including ultraviolet, UV, and infrared (IR) light, which require specialized instruments to detect. These invisible emissions carry valuable information about the aurora's energy and structure, revealing aspects of this phenomenon that remain hidden from the naked eye. Studying auroras in different wavelengths allows scientists to understand the energy levels of charged particles colliding with Earth's atmosphere. High-energy particles produce UV emissions in the upper atmosphere, which are invisible but tell researchers about the most powerful interactions occurring above our heads. Infrared light, on the other hand, is connected to heat energy and the subtle redistribution of energy in the upper layers of the atmosphere. By analysing these wavelengths, scientists can map the aurora in incredible detail, track the movement of particles, and study how solar activity influences auroral displays. Each wavelength provides a piece of the puzzle, helping researchers connect the dots between solar flares, charged particles, and the magnetic field. For observers, this hidden spectrum emphasizes that the northern lights we see with our eyes are just a portion of a far more complex and energetic display. Knowing that there's more happening beyond visible light adds depth to the experience, transforming the aurora from a beautiful sky show into a scientific marvel. Even if we cannot see these hidden colours directly, understanding their presence gives a richer appreciation of the forces shaping our planet's magnetic environment. Fact 92. UV and infrared auroras. Some auroras emit light in ultraviolet and infrared wavelengths, both invisible to human vision but detectable by satellites and specialized instruments. These wavelengths reveal details about auroral intensity and structure that visible light alone cannot provide, offering scientists a more complete understanding of the phenomenon. UV auroras are produced when high-energy charged particles collide with atoms and molecules in the upper atmosphere. Observing these emissions helps scientists track space weather, monitor solar storms, and understand how energy is deposited into the atmosphere. Infrared auroras, in contrast, are associated with heat energy and subtle changes in atmospheric composition caused by solar activity. Both types of emissions complement visible observations, giving a multi-dimensional view of auroral processes. Studying UV and infrared auroras also helps researchers understand the impact of these displays on Earth's magnetic field, satellite operations, and communication systems. While invisible to us, they play a role in shaping the space environment and have practical implications for technology. By combining observations across multiple wavelengths, scientists can model auroras more accurately, predict their behavior, and explore the connections between solar activity and geomagnetic effects. For enthusiasts, UV and infrared auroras are a reminder that the lights above our heads are part of a complex multi-layered system, with energies and patterns that extend beyond what we see. They turn the aurora into a living laboratory, a visual and scientific marvel at once. Fact 93. Auroral substorms explained. An auroral substorm is a sudden intensification of the aurora that usually lasts from a few minutes to about an hour. Substorms occur when energy stored in Earth's magnetosphere is suddenly released, sending charged particles rushing toward the upper atmosphere and creating dramatic bursts of light and motion. During substorms, auroras can brighten rapidly, change colour, and shift shape in ways that make the display almost theatrical. Observers may see curtains split apart, arcs extend across the sky, or waves ripple in patterns that seem to move in time with an invisible rhythm. These events provide scientists with real-time opportunities to study auroral mechanics, particle acceleration, and magnetic field interactions. Substorms highlight that auroras are dynamic and ever-changing. Unlike static lights, they respond to the complex interplay between the sun, solar wind, and Earth's magnetic field. Their unpredictability is part of their charm, offering viewers a one-of-a-kind experience every time. Even brief substorms can leave a lasting impression, making observers feel like witnesses to a live cosmic performance. Understanding substorms also improves aurora forecasting, as these events indicate periods of heightened geomagnetic activity. For both scientists and casual viewers, substorms are a vivid reminder of the energy constantly flowing through our planet's magnetic environment. Fact 94. Why auroras sometimes appear in circles. Occasionally, auroras form circular shapes known as auroral ovals. These rings are centered around Earth's magnetic poles and occur because charged particles are funneled along the magnetic field lines, interacting with the upper atmosphere in a roughly circular band. The auroral oval is not fixed. It shifts depending on solar activity. During geomagnetic storms, the oval expands, sometimes bringing auroras to regions much farther south than usual. In calmer conditions, the oval contracts, limiting auroral visibility to higher latitudes. Observers located near the center of the oval often see lights dancing directly overhead, while those on the edges might only catch faint arcs along the horizon. These circular auroras illustrate the close relationship between the northern lights and Earth's magnetosphere. The magnetic field shapes the movement, location, and behavior of auroral displays, creating patterns that can be predicted and studied. Circular auroras also reveal how global and localized interactions between charged particles and magnetic fields produce visually stunning phenomena that vary night by night. For viewers, witnessing a circular aurora is a reminder of the magnetic forces silently guiding the lights above us, transforming a scientific process into a breathtaking visual spectacle. Fact 95. Connection to polar lights in other planets. Auroras are not exclusive to Earth. They occur on other planets with magnetic fields, including Jupiter, Saturn, Uranus, and Neptune. These extraterrestrial auroras are created by the same basic mechanism: charged particles interacting with a planet's magnetic field and atmosphere. On Jupiter, auroras are intensified by its powerful magnetic field and interactions with its moons, creating displays far brighter and more energetic than Earth's. Saturn's auroras, often observed in ultraviolet light, are influenced by its ring system and solar wind conditions. Uranus and Neptune also produce auroras, but their unusual magnetic field orientations create patterns that differ significantly from Earth's. Studying auroras on other planets helps scientists understand Earth's auroras in a broader cosmic context. It highlights the universality of the phenomenon and shows that auroras are a signature of planetary magnetic activity throughout the solar system. Observing auroras on other worlds allows researchers to compare magnetospheric behavior, solar interactions, and atmospheric responses across different planetary environments. For observers and scientists alike, the knowledge that auroras exist beyond Earth adds another layer of fascination. It shows that the dance of charged particles and magnetic fields is not merely a local event, it is a cosmic performance, one that occurs across planets, demonstrating the universality and grandeur of this natural wonder. Fact 96. Auroras on Jupiter and Saturn. Auroras are often thought of as an Earth-only phenomenon, but they actually occur on other planets with magnetic fields as well. Jupiter and Saturn are two of the most spectacular examples, each producing auroras far more intense than anything seen on our planet. On Jupiter, the auroras are powered not just by solar wind, but also by the planet's massive magnetic field, which is the strongest of any planet in the solar system. Charged particles from the Sun and material ejected from Jupiter's volcanic moon, Io, interact with this magnetic field, creating bright, concentrated arcs of light that dwarf Earth's auroras in both size and intensity. Jupiter's auroras are most often observed in ultraviolet wavelengths, invisible to the human eye, but space telescopes capture them in dazzling clarity. The displays are not only bright but also highly dynamic, shifting and flickering as particle flows vary. Scientists study these auroras to understand how magnetic fields, particle interactions, and planetary atmospheres work together on a scale far beyond Earth's. Saturn, on the other hand, presents a different auroral experience. While still impressive, Saturn's auroras are influenced by its ring system and variable solar wind conditions, which can alter the shape and intensity of the lights. These auroras are sometimes visible in UV or even faint visible light through specialized telescopes. The auroras on Saturn demonstrate how planetary environments can modify the patterns and behavior of auroral activity, providing a fascinating comparison with both Jupiter and Earth. Studying auroras on other planets allows scientists to understand the universal mechanisms behind these lights. Charged particles, magnetic fields, and planetary atmospheres combine in predictable ways, but each world adds its own twist. Observing these auroras reminds us that the northern lights are part of a cosmic dance, not limited to Earth. They are a universal phenomenon, connecting our planet to the broader solar system and showing that the beauty of auroras is both local and interplanetary. For enthusiasts, imagining these alien auroras adds a new layer of fascination. It's not just that Earth has stunning skies, the solar system itself is alive with magnetic energy and light, making auroras a shared spectacle across planets. The lights on Jupiter and Saturn may be invisible without telescopes, but knowing they exist enhances our appreciation for the northern lights we can see with our own eyes. Fact 97. Historical solar storms and aurora. The northern lights are directly tied to solar activity, and some of the most dramatic auroras in history were the result of massive solar storms. One of the most famous is the Carrington event of 1859, when an enormous solar flare released a massive burst of charged particles that collided with Earth's magnetic field. Auroras were seen across the globe, far south of their usual polar range. Reports describe lights so bright that people could read newspapers by their glow, and telegraph systems across Europe and North America experienced disruptions and even sparks, demonstrating how auroras and technology are interconnected. Other historical solar storms created equally impressive auroral displays. In 1770, auroras were observed in unusually low latitudes, fascinating and frightening populations that had rarely seen such lights. In 1921, Auroral activity again reached unexpectedly southern locations, providing modern observers with records in newspapers, journals, and ship logs. These accounts help scientists today reconstruct historical solar activity patterns, showing how extreme solar events influence both auroras and geomagnetic conditions. Historical observations also reflect human awe and imagination. Before modern science, bright auroras were often considered omens or supernatural events. While today we understand the physics behind auroras, the historical records give us insight into the human experience of witnessing these cosmic events. Wonder, fear, and fascination combined in equal measure. Studying past auroral events also provides context for modern space weather research. Understanding the scale and intensity of historical solar storms helps prepare for future events, especially considering the technological systems that now rely on satellites and communication networks. The northern lights are not just a beautiful spectacle, they're also a visible reminder of the dynamic relationship between the Sun and Earth. Fact 98. Aurora and human health myths. Throughout history, auroras have inspired myths not only about natural forces, but also about human health. People often try to explain unusual experiences or sensations during aurora events with imaginative interpretations. Some believe that prolonged exposure to auroral light could cause headaches, dizziness, or fatigue. Others thought that the lights could bring either luck or misfortune, influencing mood, sleep, or emotional well-being. Modern science has shown that auroras do not directly impact physical health. There is no evidence that observing auroras causes illness or physiological changes. However, there are indirect psychological effects. Watching the northern lights can elicit strong emotional reactions, or joy, or even mild stress if someone is anxious about catching a perfect display. These reactions are entirely normal and part of the human experience of witnessing a rare natural phenomenon. The persistence of aurora-related health myths demonstrates how humans historically tried to interpret the mysterious. People have always sought to make sense of phenomena that defied easy explanation. Today, while we understand the science behind auroras, the legends and stories add depth to our experience, showing that emotional and cultural connections are as significant as physical observations. Even without mystical effects, the northern lights can influence mental states in subtle ways. The quiet, still nights under dancing lights encourage reflection and mindfulness. Observers often describe feelings of peace, inspiration, and a sense of connection to the natural world. In this way, auroras impact human experience, not through physical health, but through emotion and perspective. Fact 99. Future of Northern Lights research. The study of auroras continues to evolve thanks to advances in technology and observation techniques. Satellites provide global, real-time monitoring of charged particles and magnetic activity, while drones offer unique perspectives closer to the auroral displays. Artificial intelligence and predictive modeling now allow scientists to anticipate aurora events with greater accuracy, integrating solar activity, geomagnetic data, and atmospheric conditions. Citizen science is also becoming increasingly important. Enthusiasts around the world contribute photos, observations, and data, creating large-scale networks that complement professional research. This integration allows scientists to track auroral trends, study the effects of solar storms, and explore connections between auroras and technological systems like GPS and communication networks. Future research may also uncover subtle impacts of auroras on atmospheric chemistry, climate patterns, or the ionosphere, broadening our understanding of the northern lights beyond their visual beauty. As methods improve, we can capture more detailed images, analyze multiple wavelengths simultaneously, and even model auroral behavior in laboratories. The northern lights remain a focus of both scientific curiosity and public fascination. With new tools and global collaboration, research will continue to expand, ensuring that auroras remain both a subject of rigorous study and a source of wonder. Fact 100. Why the northern lights will continue to fascinate. The northern lights will always captivate people because they are a perfect blend of science, beauty, and unpredictability. Their flowing ribbons, vivid colours, and constantly changing shapes make every display unique. No two observers will experience the exact same performance, which adds to their allure. Auroras connect us to the broader universe. Watching them reminds us of the sun's energy, the planet's magnetic field, and the dynamic nature of Earth's atmosphere. They inspire art, photography, music, and literature, influencing culture across generations. Whether experienced by scientists, tourists, or indigenous communities, auroras provoke curiosity, awe, and reflection. Even with advanced technology explaining their origin, the emotional impact of witnessing auroras remains undiminished. They are a visual reminder of our connection to the cosmos, the planet, and the rhythms of nature. As long as humans look to the sky, the northern lights will continue to draw people north, inspire creativity, and evoke wonder, proving that some natural phenomena are timeless in their ability to fascinate.